Continuing the proof, if I want to wrangle this, or particularly this, to look like the appropriate thing to have in the derivative of f with g inside of it, well, what would that even look like? That would look like f of x, except with g inside of it. So rather than f of x, it would just be f of g of x. And then f of g of x minus whatever's in the denominator, and I'm putting this in the denominator. So really what I would like to have instead of this is I would like to have g of x minus this. And so I put that here. And in fact, if you look at the algebra, it's kind of fantastic that the algebra just works out, right? If you distributed the negative and collected terms, this really is the same thing as this right here. So in fact, not only is it what I want, but it's exactly equal to the thing I have. So I just manipulate the expression, make it look like this. I group this together with h, right? I move the h underneath here and sort of just swap them out. And this is just the derivative of g already, letting h go to 0. Now, going from here to here, and by the way, this already was the weakness in the proof, and you could easily be forgiven for not spotting it, but the important point here is that g of x minus g of x minus h could be 0, right? It could even sort of be pathologically 0 in a sense, like it could be that you can't just pick fortunate values of h to avoid 0. So anyway, this is a bit of an excessive technicality, but it does matter. And so if you wanted a fully rigorous proof, you'd have to account for it. And I leave that, like I've said, to a real analysis course. But that's really the main weak part of this whole argument. In any case, continuing with this weak argument, the next thing to notice is that as h goes to 0, this also goes to 0, which is really what we want, because we want to kind of regard this thing as just some variable that is going to 0, because that's what we need for the derivative statement, right? I mean, what we really need, let's call the variable z. So what I really want is to regard this as some variable z, so that what I'm talking about is f of x, but really it's f of g of x, because I've got the composition, minus f of x minus h, except that instead of x, again, we're really talking about g of x, and instead of h, we're really talking about z. And we want to be talking about where z goes to 0, as is, standard in the definition of the limit. But notice, as h goes to 0, you get g of x approaching g of x, and you're taking the difference, so it does go to 0. So really, as h goes to 0, this thing also goes to 0, and we might as well just regard it as some variable that goes to 0. And so rather than having this noise, just think of it as some variable z that goes to 0. That's all we really need there, and that's exactly what we have there. So this really is the derivative of f with g inside of it. And this, as I've said, is g prime, and there you have it. That's the proof of the chain rule.